Hello, welcome back to 129, Object-Oriented Programming. Today we're going to review that rectangle homework. I did a little poll earlier outside of class to see how long that took people on average, because I had some folks asking me if perhaps they spent too long on it. So I'm just going to repeat that poll again and ask how long did the rectangle homework take you? And the estimated completion time for pretty much every homework here is about 3 or 4 hours per week. So for homework like the rectangle one, I expect about that much. That one might have been a little bit on the maybe longer end because it's obviously pretty complicated. But yeah, the expectation's around 3 or 4 hours a week. So if you're anywhere between the 3 and let's say 6 hour mark, then you're pretty much in the same boat as everybody else, I would say. You're pretty much on par. And as we go through this, I'm going to try to connect it to some of the stuff that we've learned for swing, some of the stuff that you can apply to the next homework here. So I'm going to call this package homework 3 solution. I'm going to make the driver first. Check the box. Let me see if I can find where I put the driver that I gave you. I think it's, there we go. So I'll just copy that in. Easier than having to import it. Alright. Looks like that copied in successfully. And most of it's going to have to be commented out here, obviously. So let's go ahead and just block comment out the whole thing, and then I'll add stuff back in as I go. So just everything commented out. And then you had 2 classes. You had point, and you had rect. Now, point is the same as point in swing. And in Java in general, actually, point comes from the Java library. But we usually use point2D instead of point. You actually don't need to worry about the distinction. It's just called point when you type it out. But point has 2 coordinates. Obviously, point3D has 3, an x, y, and a z. Point's got 2, so you've got your int x, your int y. You could put them on the same line. And if you put them on the same line, you write a comment for it, for example, coordinates for this point, then you can actually see that the comment, when you hover over, applies to both variables. So if they have the same documentation, that's one way to do it. And then you need a simple constructor that just connects those 2 dots for you. So we need to take an x and a y and link them to the fields at the top. There we go. So that's point done, and then we can go to our driver and try it out. I think we only have one thing here that relates to just point, so let's go ahead and run that. And we've got the origin at 0, 0. Okay, great. Now on to rect. So rect was an array of points most easily. In fact, I think it specified in the requirements that you had to use an array of points, so I took off a little if you didn't. Some people made both an array of points and use some points individually. Really no need for that. You just need the array because you just need those 4 points for the corners. Obviously it's 4 points big. A lot of bad names here. A lot of people named it like rect or rectangles or something. It's not an array of rectangles, it's an array of points. And it describes what? Well, it describes the 4 corners of the rectangle. So corners is a good name. If you're a little lazier, you'd go with points. Some people call it point. That doesn't make sense. There's more than one of them. So I'd go with points. Let's go with points here. And of course, that's an array of point. So there we go. Now, a couple assignments ago, I showed you how to make the indexes have a more understandable name. And I don't think anybody really used that feature. Maybe one person did. So let's go over that again. So if you have 4 points and you've been given specifications on what they're supposed to be. So index 0 is supposed to be the top left, and index 1 is supposed to be the top right. You really ought to write that down, and you really ought to write that down in such a way that you can access it very easily anywhere in the class as you're working on it. And the main advantage to that is that further down we got to like translate and scale and all these things. A lot of people ended up doing something like this. They would reference like points of 2 greater than p dot x or something, you know. And what's 2? You know, I don't know what 2 is. And if I haven't programmed this in, let's say, a week and I'm coming back to it, I'm certainly not going to remember what index 2 is supposed to be. Now, you could write it in a comment, but then, of course, you have to read the comments just to understand it. The easier way is to give each index a simple English name. So I'm going to give index 0 the name top left. Whoops, got an extra equals there. So top left is just the number 0. There's nothing fancy about that. It's just the number 0. But when I access points of 0, rather than accessing it as points of 0, I'm going to access it as points of top left. And this, unlike saying points of 0, is not ambiguous. It's very clear what you're trying to do. You're trying to get the top left point. And even if there was a bug here, and let's say that the top left ended up being the wrong number or something, like the mistake I made last time, actually, as I was doing this, well, it'd be easier to fix because at least you can see the intent. The intent was to access the bottom right or bottom left or whatever point, whereas if you just say points of 2, I don't know what your intent is. It's very unclear. I'd have to read either your comments or something else to understand what your intent is there. The next choice you have is whether or not you want to store width and height in a field or whether or not you want to recompute them mathematically each time. So this is a perfect rectangle, and obviously it's easy to just compute the width and the height on demand. You just subtract the x distance between the left and the right side points or the y distance between the top and the bottom, so that's doable. Or you could store them, which is what I'm going to do because I think this is the option that fewer people picked. So let's say I also want to store the width and the height. This creates a little bit of extra work in some places because you have to make sure that you're updating them as you go. So for example, when you scale the shape, you have to update the width and height too. Of course, scale actually returns a new rectangle, so you get to sidestep that issue. But it's to your advantage, I think, because you don't have to do as much math. So I prefer to store things rather than recomputing them when it's favorable. And yet, generally speaking, that's the trade-off that you want to make. You want to trade off having an extra variable versus having to do math every time you want to compute something. So if you've got a width and you're recomputing it every time that somebody wants it, then maybe you should just store it. Maybe that's the easier way to do it. Of course, both are fine. Okay, so the first constructor for the rectangle takes an x, a y, a width, and a height. All right, so the width and height part are pretty easy. I'm going to set those up. There we go. I don't have to compute them mathematically now. I have them stored. As for the 4 points, the 4 corners of the rectangle, well, the top left one, so the index 0, that's going to just be xy. So we're going to make a new point there and put it at xy. A few people had trouble with that syntax. The fact that you created the array up here, you created the array of points up there, does not mean that all the points inside it have been made yet. So some people couldn't figure out that they needed to make a new point and kept trying to do something like this. So they were going like points of top left or points of 0, whatever you had, and they would say dot x equals, and then they tried to do it like that. But points of 0 doesn't exist yet. You haven't yet made it. All the points in this array are null. And if you go back and think about what you learned in 128, if you made an array of strings when they started, they would all be null too. And of course you wouldn't be able to access, for example, the length of the string at index 0 because there isn't one yet. It's still null. Until you've actually gone ahead and made all the points, you can't access them. So we make our point of top left here. We're going to make right next. So right is just going to be x plus width away. And then we're going to make our bottom left. Bottom left is going to be at the same x location, but then remember down is positive, so it's y plus height away. And then the bottom right is going to be plus width and plus height away. So that's the bottom corner of the rectangle. Let me sketch that out real quick if that's confusing to anybody. So you have top left up there, and then you have top right up there, and then you have bottom left, and then you have bottom right. So top left is at xy, the top right is at x plus the width, bottom left is at the same x as top left, but then it's plus the height instead, and bottom right is at x plus width and y plus height. I can leave that sketch there too. It's a helpful thing to do. It's a helpful kind of comment. And again, since I gave everything a plain name, I gave all the indexes a plain English name, it's easier to reference them than if I had to say top left corner, top right corner. No, it's just the index name, so it's very obvious. And then you had to make another constructor. This one's kind of tedious, right? You had to specify all 8 points of the rectangle. So I'm just going to give them bad variable names to be a little lazy here. x2, y2, x3, y3, x4, y4. We'll see that the built-in rectangle has the same kind of constructor. You can give it an array of points, but we're not going to use this particularly often. So I'm going to use my same declaration here, except now I'm going to change it to that's going to be x1, y1, that's going to be x2, y2, and this was all just in the description in terms of how you were supposed to specify these. So the top left point was supposed to be x1, y1, the bottom right is supposed to be x4, y4, and so forth. Now I also need to do the width and the height since I've committed to storing those. Most of the people who computed it mathematically figured this out. Width is the top left corners, or the top right corners x minus the top left corners x, or you can do the bottom instead. So I can say points of top right dot x minus points of top left dot x. That would work. I also could have just used the x's that I got here as arguments, but I would find that more confusing because this is pretty clear in my opinion. You're subtracting the top right x position minus the top left x position. And again, if you had just had indexes here, this would be a pretty confusing statement. With the addition of those words representing the indexes, it makes it a little bit clearer. Height, a little bit more complicated because you have to remember that swing has this very backward system where the bottom is the highest point. So we're actually subtracting the top from the bottom. So we want to subtract the bottom right from the top right y position. And we could have done this on the left side too, obviously, and likewise for the width we could have taken the bottom instead. It doesn't matter because for a rectangle it's the same. Let's see, what did we have to do next? Let's just go back to the driver and see what the next thing in the code is, so we can just do it that way. Well, the next thing it looks like is the toString method, if we got down to here. So let's write that next. Let's write points toString first, so that we can do rectangles after that. So we're going to make point toString. I saw some pretty bad ones here in terms of how you printed it out. You got to put a little bit of effort into making it look nice, right? Otherwise you're just going to end up irritating everybody who has to look at it. So we're going to print the x, and then we're going to print the y, and we're going to put some spaces between them, and we're going to make sure that it doesn't look awful. There we go. So that's all you really need to do. That's all I'm expecting. And if you really wanted to go above and beyond, you could maybe put some parentheses around them too. There you go. Now you've really gone above and beyond. Okay, and then to print the rectangle out, a lot of people miss this little touch. You just want to use the toString method that you wrote for the points and just loop through all the points that you have and access it. You didn't have to do anything beyond that. Now here I'm going to build a little bit more of a complicated one. I'm going to start the string as rect width because I want to put that first, and then I want to put the list of the points. And then I'm going to add all of the different toString methods for the points. So out plus equals, and then I want to do points of I and use the toString method there. And then I'm also going to add a extra space, because otherwise they'll all be smushed together. Okay, and then I can return out here. Alright, so I started with the words rect width, I looped through the points array, and I added the different points values to string, and then I added a little space on top of that. Okay, so let's see if I can print these out. I have a couple here, I think, right? Yeah. I have that and that. Those two should print out. So I should have a rectangle. I have beta is a rect with x0, y0, x2, y0, that seems right, x0, y4, that seems right, and x2, y4, that seems right. Okay, so for a rectangle that starts at 0, 0 and is 2 by 4 big, that all seems accurate to me. And then I had this extra line here that was kind of a hint to you about another method that would be useful. So the top left corner of beta is at, and then I had a beta.getX and a beta.getY call. There was a lot of confusion there. So doesn't point have getX and getY? Sure, point probably has those things. You could have done that instead of making them public like I did for simplicity here. You could have added a getX and a getY here. So what would a rectangle getX and getY look like? Well, I said in the comment here, in the printout, it says the top left corner of beta is at, so it's kind of supposed to be in spec there, and then of course the example printout shows you that it's supposed to be 0, 0. It's supposed to be the top left corner of the rectangle you just made. So what you're really returning there when you ask for getX and getY is the coordinates of the top left corner, which is again exactly how it works in the swing rectangle. When you get x and get y of a rectangle in swing, you are actually getting the coordinates of the top left corner. So how do you get the coordinates of the top left corner? Well, it's the points array, the top left spot, which is index 0, and we're just going to return the x position in that spot. Okay, not a lot of people made the x and the y field of points public too. It was more common to use a getter. You don't always have to use getters and setters. It's definitely a good habit to get into. A lot of organizations kind of mandate it, but it's perfectly fine to just do it this way as well whenever you don't need to protect those fields for whatever reason. And you'll see that in Swing's rectangle, you can modify the x and the y directly. Okay, so the top left corner, it should tell me that it's at 0, 0. Lovely, it is at 0, 0. All right, next I want to look at get width and get height. Those are going to be pretty easy. I could even just make the fields public as I have here, and I could just, rather than making methods for those things, modify the driver here. I didn't say that you couldn't necessarily, I just said that you had to have a method to get these. So you could have just done beta.width and beta.height here instead, since they are currently public. But those kinds of variables, we don't want those to be public, because we don't want you to be able to change the width and the height of a rectangle without changing its other properties. That's something that we should actually make private, because of course if you changed the width of the rectangle without actually moving the points, then the width would be inaccurate. So if we made that field public, you could change the width without changing any of the points. That would make it inaccurate. We don't want that. So we just want to be able to get the width and the height without being able to modify them. And if I go back to my driver, it'll tell me that that method is missing. You can always automatically add it that way. Of course, it's telling me that it's going to be a string, which is not correct. And that's the peril of having Eclipse automatically generate things for you. It's not always the most accurate. In fact, it should really be an int here, because my width is an int, and all we want to do is return width. So I saw at least one person run into that problem, where they had Eclipse automatically generate the methods for them, and Eclipse thought, well, you probably want a string here, since this is inside of a print statement, where no, you don't want a string. You want an int, of course. You want the width and the height as an integer. Okay, with that complete, I now get beta is 2 units wide and 4 units tall, which is correct. It is 2 by 4. Next is the contains method, it looks like. So I needed to check if the rectangle contains a point. The most common mistake here was people just looping through the points array and checking if the point was in any one of the corners, which isn't enough. You have to actually check if the point's inside the rectangle. And then the second most common mistake was people just checking it against the top left and the top or bottom right corner, just those two corners, and not checking the rest of it. Another common mistake was using uppercase Boolean with a B instead of lowercase Boolean, like this. Now, uppercase Boolean is perfectly fine, except that it's the wrapper class. It's the one that has those extra methods attached to it, and that means it takes up more memory, and it has a lot of additional baggage. So what we really want is the primitive, the basic Boolean, and that's the one we're going to use pretty much all the time in this class. In fact, we won't really have any application for the Boolean wrapper class, I don't think, because it doesn't have a lot of features in there. It only has a couple of simple methods like toString and things like that. So let's look at how you would do this. So if the point's x position is bigger than the left-hand side, so it would be points of top left dot x. Most people got that part, but you also have to check that it's smaller than the right-hand side. And I also said the ties have to still count, so it would actually be less than or equal. But I didn't take off for anybody who didn't break ties the right way. Then top right, smaller than top right. X position. Okay, and then the same thing for the y. So I'm going to put that on a different line for clarity, although auto format will break it. So I want the y position to be bigger than the top, but smaller than the bottom, right? Because the bottom is the larger y, because down is positive. So I think I've gone ahead and done everything correctly there. I might have made a typo. I didn't take off if you just made a mistake. Notice I used top left for both of the y coordinates. I used the right side for the other side. It doesn't matter. You could have used either of the bottom points, either of the top points for the y location. But this way, again, with the plain English names, it's clearer that you're comparing the top's y against the bottom's y and the left's x against the right's x. It's a lot easier to see that than if you just had four, well, it'd be 3 different random indexes here. It'd be quite hard to read, right? Most of yours was quite hard to read in that part. In that case, we'll return true, and otherwise we'll return false. Now again, my preference when you have a decision that only goes 2 ways is to make sure that it's an if-else branch. Some people did the default return that just hangs out on the bottom. That's fine too, but I would rather have it branch off there. And with that, we can actually build the contains for the rectangle very easily. This is the part where I think the most people struggled. How do you tell if the rectangle contains another rectangle? I'll call it rect other. And it's actually quite simple. You're just looping through the 4 corners of the other rectangle, and if any of them are not inside of this rectangle, well, then the other rectangle must not be wholly contained inside of this one. Some people only checked the top left and the bottom right point, again, of the other rectangle. That works for rectangles that are in the default orientation. Obviously, it doesn't work anymore once you get to like diamonds and things like that, but you didn't have to support those things, so I would have given you full credit there. But the approach I'm looking for is that you loop through others points array. So we want to say I is less than other. This was the difficult part here. How do you access others points array? Well, if it's public, which it is, then that's easy. You just say other dot points. If you made it private, which you probably should have, but I didn't mandate that you had to, then you would have to have a get points method. So other dot points dot length. I'm going to loop through all the points in other and see if they are contained inside this one. So if other dot points of I What do I want to do with it? Well, I want to see if this rectangle contains that point. So it would be this dot contains, and then that other dot points of I. Okay, and if it does, then I do nothing, I continue. Because at this point I don't know that it's true that it contains all the points. If it doesn't, oh well, if any of the points aren't contained, then I have to return false here right away. As soon as I see any corner that's not inside of this one, I have to return false. So what I could say is that if this rectangle doesn't contain that other point, I'm going to return false. And if I've made it through all the points without detecting any that are not inside, then this must be true. I must have found it to be true for all 4 points. So this is the most concise way, I think, of expressing that all 4 points are inside. Now, of course, you could have omitted the keyword this. As always, it's inferred. I definitely like to see use of this when there's another rectangle or another object of the same type in the same method. I find it to be easier to read when you can differentiate this rectangle versus the other rectangle. So I want to see if this rectangle contains the other's 4 points. And of course, you could have just made 4 if statements here, 4 nested if statements for the 4 points. I think I would have taken off maybe 1 or 2 points if you just did nested if statements like that to check all 4 points instead of a loop. So try to get comfortable with looping through an array that you get from another object, because it's a very complicated call, right? It has a lot of layers, other, dot points, dot length. There's a few different layers of calls there. But it's something you ought to get comfortable with because it's something that we'll do pretty often, especially in Swing. Now, both of these methods, the contains point and the contains other, are found in Swing. Swing can do a contains for a point and a contains for a rectangle. And they work exactly this way. If the point is inside, it returns true. If not, it returns false. And for a rectangle, if the other rectangle is completely inside of this one, then it returns true. Otherwise, it returns false. And completely inside is basically just that the 4 corners are inside of this. There's also another group of methods, intersect, and that checks only if one of the corners of the other rectangle is inside, basically. So if they're touching at all, then they're intersecting. But we're not going to look into that yet. We will look into that soon. So contains is total containment. The other rectangle has to be completely inside of this one. That's something that a lot of people forget when we get into Swing later. Now that you've written it yourself, hopefully you'll remember that. I think that lets me uncomment quite a long way down in the driver. So I'll start with this part here. The contains of 1, 1 and the contains of beta. So alpha contains 1, 1. That's correct. Alpha contains beta, which is a rectangle at the following coordinates, etc. Next, I want to do translate. So I'm going to do translate next. Translate should work a lot like contains. So if you had done contains at this point, you'd have some of what you needed for translate. Translate modifies the points of this rectangle and moves them over by the x and y value given. In fact, rather than saying x and y, I'm going to call these x move and y move because these don't represent a coordinate, they represent a distance to move. I'm going to loop through all the points again. I'm going to copy it from toString because I already have that loop. There's no need to rewrite it again. Rather than printing out each point, I'm going to modify each point's x position. So points of I dot x plus equals x move and points of I dot y plus equals y move. Many people who relied on getters and setters for the x and y values in point ended up with a much longer line here. Of course, if you could only access x through get, it would have to be points.getx, and then of course you can't do plus equals, it would have to be points of I dot set x, points of I dot get x, plus to move it'd be a little longer. But if you had access to those, if you had made them public, which I didn't say you couldn't, then you could just do this, it'd be a lot easier. Let's uncomment that and see if we're up to that point then. I have to save for it to update that that method exists. So there's translate. Beta has now moved. It used to be at 0, 0. Now it's at 2, 2 for the top left corner. Of course, the top right was at 2, 0. Now it's at 4, 2. Moved over by 2 in both directions. The next coordinate was at 0, 4. Now it's at 2, 6. And it's still the same size. So remember, the width and the height don't change when a rectangle moves. Just convenient. Didn't have to update it there. And now on this next part, it shouldn't print anything, so I should get the same output because alpha is no longer inside beta now that beta has moved, and I don't get any output, so it looks like that works. Next is going to be scale. Scale was probably the hardest method here, I think, although most people did well on scale. Most people, if they got any methods wrong, they got the contains ones wrong, or at least they didn't do them as well as they could have. So scale returns a rectangle and doesn't modify the points of this one. I think I wanted to take a float there, but I don't remember. Let's take a float anyway. X scale, Y scale. It doesn't modify this one, so you don't want to change this rectangle's points or this rectangle's width or this rectangle's height. And actually, scale is completable very easily in one line. So you're going to return a new rectangle that has the same top left coordinate. All right, and how do you get the top left coordinate? Well, there's a couple of ways. You could access the point of top left and get its x and y that way, or you can use the methods that you already had to write earlier, the get x and the get y. This is part of the reason why I made you write these earlier, because it makes scale a lot easier when you have them. So I'm going to make it clear that I'm using this rectangle. So again, this is optional here because it can be inferred. There is no other get x and get y method, but I like it here for the clarity. And then for the width and the height, well, if you stored the width and the height, this was easy, right? It's just the width times the x scale and the height times the y scale. A lot of people ended up computing them here mathematically again, and that's fine, of course, but you don't have to if you had already stored them. If you took floats as an argument, then of course you need to cast the math to an integer. That makes this line a little bit more hairy, but still very manageable. So if you didn't have width stored as a field like I do, then you would have had to use a get width or a get height method. Some people did that. Or you can just recompute them again, but that's probably the least good object-oriented way to do it. You don't want to be redoing math in multiple different places, especially if it's the same math. You want to have a method that does it for you. Okay. So the constructor that I used here was the first one, the one that takes an x, y, width, and a height, because that's just the easiest one to use here. I have all those values already. I have an x, a y, a width, and a height that I want, and I just have to scale by what I'm given. So let's see if that worked out for bigger beta here. So bigger beta is a rect. It starts at the same place, 2, 2. Beta also starts at 2, 2. The top left corner is still 2, 2. And the original was 2 units wide and 4 units tall. This one is 4 units wide and 16 units tall. I scaled it 2 times on the width and 4 times on the height. 2 times 2 is 4, so that's correct. And 4 times 4 is 16, so that's correct as well. And I also would have definitely encouraged you to try these out with other values. So even though I give you a main method for testing, sometimes you're going to want to try it out with some other values too. I'm going to skip the bonus. I had some extra testing that I made for the bonus too, but I'm going to skip over it. The big bonus nobody got. The big bonus would have been to use trigonometry, so to use tangent, calculate the length of the 2 line segments for each of the 4 corners and make sure that it's 90 degrees for all of the 4 corners. That would have been the big bonus to accept diamonds too. So you calculate the length of the line segments between all of the different points and then use trig to make sure it's 90 degrees between all those guys. There was also a little mathematical trick you could use. You could get the slope. The slope is pretty easy to get between 2 points, right? So you get the slope of the 4 lines that make up the rectangle, and if you have 2 matching pairs of slopes, then you either have a rectangle or a parallelogram. So I would have given you most of the credit there because you were close enough. And then the lowest budget solution which I would have given you credit for as well, would have been to check that the x-coordinate of both the left sides is the same, the x-coordinate of both the right sides is the same, the y-coordinate of both the top points is the same, and the y-coordinate of both the bottom points is the same. That tells you that it's a rectangle, but does not handle diamonds and other rotated rectangular shapes. Okay, so that's going to be it for the homework. Obviously, I'll upload this. I went through it pretty quick, but the goal today is to do a little bit more in swing with some of the stuff that we've learned from the rectangle here. Now, your exam is not going to have any swing on it. Most of it is going to be material very much like the homeworks. The exam is going to be writing code. So it's like the quizzes in the sense that it's delivered on Canvas. The kind of difficulty level of the questions is similar, but you have a lot more time for them. So if your problem is the time crunch, then it should be a little bit easier for you on the exam. But you do have to write code, which means that the best thing you can do to prepare for the exam is make sure your Eclipse is ready, that you have all of the previous examples on Canvas loaded into Eclipse. Maybe I'll do a single, yeah, I will actually. I'll upload a single package of all of the examples that we've done so far, including the Homework 3 solution, as one file, so you can just drag them all in if you haven't been doing that already. And yeah, that's the best thing you can do to prepare. Make sure you have all the examples loaded, you know what they all do, you know where to find all the different code that you need to find, because there won't be anything new on the exam. It's all pretty much something that we've done before, just in a slightly different flavor. And you only have to write about 20, maybe a little bit more lines of code to complete it. So it's mostly about knowing how than the mechanics of writing. If you're a slow typist, that's not going to play into it too much. It's more about knowing what to write. So I'll basically ask you to write a couple very short classes, very much like what we've written already. Okay, we had a bit in the swing intro last time. I'm going to make a new package for this. I'm going to call it Swing Object Intro. Swing Object Intro. And I'm going to take another poll here. Let's see. For those of you who started the next homework, who started homework 4, is it 4? I think it's 4. For your square thingy. So for homework 4, you have a limit on how many lines you can write in the panel class. That's the one that is your display. I'm going to make my driver and my panel here while I wait for the results of the poll. And the hardest part, I think, is going to be splitting that code away from the panel. So you can only write so much in the panel. I think everybody should be able to finish the homework if I didn't have that restriction, because it's pretty easy to do everything in the panel. It's that restriction that makes it particularly difficult. So I'm going to copy my code from last time's driver to create the display. You should already have this available for you as well. I have the basic swing starter available for you on Canvas. That's just the most bare minimum swing code without any frills or anything. So let's call this swing object intro. It doesn't have any comments, it doesn't have any extra, it just has the click keyboard functionality and the ability to paint. Okay, let's also copy the code in for the display, although I'm going to be getting rid of quite a lot of it. Actually, hopefully I have the basic starter somewhere, maybe. I don't remember if I've preserved it from any of my other classes. I don't think I have. I'll just copy the one you have from Canvas, actually, for simplicity's sake. So let's copy the one you have from Canvas. And let me show you even how to load it in. So actually, I'm going to delete both of the new classes that I just made. I'm going to delete those. And let me show you how I would start this project from the sampler that you got. What's the quickest way to load it in? I've gone through this a couple times a little bit, but I think that a lot of people are still confused with it. So I would go to the assignment. You have your super basic starter there. I added an extra S as a link. You'd click that, and it's going to download it for you. So I'm going to save it to my downloads there. Lovely. And then I'm going to make my way to my downloads folder. I trust that you know how to do that already. And then I'm going to unzip it. This part I'm not picturing. Oop, I already have it unzipped earlier. Whoops, so I'll just put it somewhere else. I've already gone through that. Alright, well, anyway, let me show you that part too, actually, just in case. So once you have it downloaded, you'll have it downloaded wherever it is on your file system. You're going to unzip it. I use 7-zip. You can use whatever unzipper you want to extract it here. There you have the source files in a folder now, and all you have to do in order to get started with them is drag them into Eclipse where you want them. So I want them in my swing object intro. I'll drop them in there. It'll ask me if I want to copy them, and I do, because I don't want to work in my downloads folder, of course. And that's it. Now I can close out of my file system there, and I have them loaded in. You notice they load in with errors because the package name doesn't match. So I can just let it change it for me there. It's the second option. Change package declaration. Awesome. And now that's loaded in. If I save, everything will just kind of fix itself. So I just had to change the package declaration to mine. Okay. Now, I don't like the name iSimplePanel, so I'm going to change that. And the quickest way to change the name everywhere in your program is to right-click on it, go to Refactor, and go to Rename, and I'll change it to Display, and hit Enter. And it will not only change it here, it will also change it in the other class here, everywhere that it occurred. So just a convenient name to do a quick renaming of your variable everywhere that it occurs. So have your variable selected or your class selected, right-click on it, go to Refactor, go to Rename, type what you want, hit Enter, and it will change it everywhere it occurs in your program. Alright, so if I launch this, I get the standard light gray swing background with no frills. Let's call it my swing objects intro. And now let's make an object. So I just want to show you again that this method or this class is blank. All the methods are blank. I have a basic click and a basic key press, and that's it. So no frills there either. I've got my paint component ready, but nothing's being drawn. I've got all of my different listeners enabled. I already set them all up so you can get the mouse and the keyboard and whatever, and you can get clicks. So it says click when you click, then it echoes the key code back to you when you press a key. Okay, so let's make an object, which is what you have to do. I'm going to make an object called, why don't you guys tell me, what do you want to draw to the screen? What kind of thing? It can be a stick figure or a smiley face. You can name an animal, household item, whatever you want me to draw. I'm going to do my best to draw it using the powers of swing art. So in either chat, what do you want me to draw? What kind of object do you want? Go with toaster, spaghetti. Snake's a good one. I can do snakes really well. Balloons. Awesome at balloons. The power you possess would just be blank, and that wouldn't be an interesting drawing. It's got to be something visual. The snake. Oh, you asked for it. All right, let's do the snake. I'm very good at a snake. Okay, so two kinds of snake that I can do. I can do an oval and a rectangle snake. I'm going to do a rectangle snake because you have to do a rectangle for your homework, so I think it's only fair. Okay, so to get an object to draw to the screen, obviously it needs to have one of these shapes in order to, have something that's drawable. So I'm going to give the snake a rectangle. So it's imported there, rectangle 2D.double, and I'm going to call this the snake's body. Okay, and let's not specify a location for it just yet. We'll do that further down. And then I'm also going to do, what do they call it? I think ellipse 2D? Yeah, ellipse 2D. We'll call it eyeball. So we're going to make the snake a body and an eyeball. That's all a snake is, really, so you picked an interesting one for sure. Okay, we could store the x and the y coordinate of the snake as well, right? But we don't have to, and the reason that we don't have to is because the rectangle that comprises the snake will store the x and the y coordinate for us. So this is something that we haven't done before. We're taking another class, the rectangle, the body of the snake, and we're going to use the x and the y coordinates of that rectangle to represent our snake visually. So if I make a new snake, I'm going to take an x, I'm going to take a y, I'm going to take a width, and I'm going to take a height. Okay, but instead of storing those here, I'm going to pass all of those along to the body. So I'm going to say that body is a new rectangle, and the body is going to get my x, y, width, and height that I took in as an argument. So my snake's constructor takes an x, a y, width, and a height, but all of that passes along to the body. Creates a new snake at the specified x and y position, who is width long and height fat. And all my snakes are created horizontally. Okay, so width is the length of the snake, and height is the fatness of the snake. Okay, now how do I get the snake to draw to the screen? Well, first, as for your homework, you might want to give the snake some characteristics besides the fact that it's, got a rectangle and an eyeball. So let's give the snake a little bit of character. Let's give the snake a color. I'm going to call this its base color. And what should the base color of our snake be? What kind of snake do we have? Yellow, red, blue? Give me a base color in either chat. And then we're also going to do eye color. Let's do eye color as well. Base color for our snake. How do we give it a base color? Go with boring yellow. Lame. I was going to give it some cool RGB values. No, the eyes we're going to do in a random color, like we did for your homework. Snake is created. This snake will be the default yellow color with randomly colored eyes. So how do I randomly generate the eye color? Well, I have to just specify it here in the constructor. The eye color is a new color. How do you get a random RGB value? So in either chat, how do I get a random RGB value here? So I want a random RGB value for the eyes. How do I get a random RGB value? How do I get a color of a random RGB value? Show me the line to do that. while you're thinking about it, I'm going to make another constructor. Let's say that I don't want my snake to be the boring default yellow. Let's say that I want to be able to specify my snake's color. So I'm going to make this constructor over again. And I'm going to add one more argument to it. I'm going to add an argument for snake color. Somebody said int math.random times 255 for the color. This is not going to get you a random RGB color. This is going to get you a random shade of gray. If you read what it says for colors constructor, if you do one argument and an integer, it's going to be the red component in bits 16 to 23, the green component in bits 8 through 15, and the blue component in bits 0 through 7. Probably not what you meant. Actually, you can do this, but, and I don't encourage this, you want to multiply by 0x FFF. This is actually the fastest way to get a random color, multiplying by FFF. But that's confusing as heck. We're not going to do that. That goes back to hex colors and stuff, so don't even worry about it. That's confusing. The first answer, math.random generators for each RGB colors, is right, so we would just copy that 3 times there. So that works. That's one way to do it. You can also remember that color takes a constructor that takes 3 floats and uses those to scale to 255. So you can also do this. You can do 3 floats, and then you get to omit the 255. All of these are valid approaches to making a random color. This is the shortest one that doesn't look stupid, but the 255 one is fine too. So if you find that easier to understand, use that. Since that's the answer I got in chat, I'm going to roll with it. So that's a random eye color there. Awesome. Now on to my new constructor that I've created. So I've added an extra parameter here, the snake color. And for your homework, you're going to have to do the same thing. All of the rectangles have a random color except one. One has a specific color. One is cyan. So think about how you're going to implement your homework in a similar way. So this creates, I'll just copy the comment here, a new snake at the specified location, and the snake will be the specified color with randomly colored eyes. So the eye color remains random. I just copied that in there. However, the snake's color, the base color, is now what's given as an argument. So how do I do that? How do I set the snake's base color to the one I got in the constructor here in either chat? How do I do that? Let me scroll up a little so you can see it better. How do I set the snake's base color to the one I got in the constructor here? And then follow-up question, is it a problem that I said base color equals yellow at the top? Is that a problem? I'll take a poll for that one. So the answer I got in chat is correct there. The base color equals the snake color that you got as an argument. So since they're not named the same thing, I don't have to use that keyword this. Remember, it's always inferred if you don't have any ambiguity. But many people would argue that you should always use it when you're referring to a field. Those people end up with really long code. But if you want to be one of those people, you are certainly encouraged to do so. I, again, prefer to just look at the color of the variables. I see it's teal, so I know it's a field. It's easier for me. Use the tools you have available for you. The IDE lets you color them separately, so go for it. Oh, I put the poll in a different chat than usual. That's my bad. It's in the in-class chat this time. So is it a problem that I put that base color equals yellow on the top? So remember, the order that everything executes in, the stuff at the top goes first, then the constructor. So this color equals yellow, it's going to get overwritten down here anyway. So no, it's fine, it doesn't matter. It'll get set to yellow, and then it'll immediately get set to base color before it even does anything. So it'll never be yellow, it'll actually be this next color as soon as the object is created, for any practical reason anyway. Okay, so I've got snake with a body, a base color, and an eye color. The snake's body is a rectangle. What am I forgetting? What have I forgotten to place? Which variable have I neglected? There's a field that I have completely neglected. What field did I neglect? In either chat. I still have to set this thing up. The frame. I think I did everything I needed to do for the frame, the objects intro and stuff. I haven't actually put the snake on the display yet, but I'm talking about snake. Yeah, I forgot about the eyeball. I forgot to place the eyeball. So let's make some goals here for a snake. If I want a snake like this with an eyeball right there, how can I accomplish that? What's the line of code that I need to add to the constructor to get that eyeball right there? Right in that very spot. And what do I do? Now remember that the top left corner of body is right there. Eyeball is going to have this imaginary square around it. And when you designate an ellipse or whatever, it actually uses that top left corner there in order to specify it for you. So it's actually the top left corner right there that's being used to give me the location of the eyeball. Somebody's a hater and says that my snake looks like a wooden plank. Let's see your swing snake then, huh? We can add more detail. I'll be the next homework. No, plank has 2 eyes. This is a side profile of a snake. So how do I put the eyeball right there? What do I do? Let's see, I don't know. Let's go, you come up with the answer in either chat. Eyeball is the new ellipse 2D, not double. I have to give it an X, Y, width and height. What do I do? What do I do? Well, it's obviously got to be smaller than the snake, but I want it to be some proportion of the snake's size. And my specs here say it's got to be a perfect circle, which means the width and the height have to be the same values. So let's use the snake's height and scale the eye to that. Let's say that the size of the eyeball is the height over 4. So it's 1/4 of the height of the snake, the eyeball is. The eyeball's diameter is 1/4 of the height of the snake. But what do I do for the X and the Y position? Because if I do it the way I've got it now, then it's going to end up being jammed into my snake's top corner there like this. And that's not what I want. I don't want it jammed up there. I want it scooted over here where eyeballs should be. I got a lot of criticism on my snake here. I'm pretty sure I know how to draw a snake. I think this is definitely a snake. Okay, someone said X plus 10, Y plus 10. That'll work. That'll space it out. Now, the specs are that it's further from the front than from the top, but whatever. Let's see how that looks. Okay, I'll copy that over into the body as well. Okay, now for your homework and pretty much for all future drawing of different objects to the screen, what we're going to do is make a method called draw. A method called draw. And our draw method is going to accept a graphics 2D. Now remember, that's that pen that you need. If you're not holding the pen, you can't draw to the screen. And so what we're going to do is we're going to pass the pen to every object that wants to draw by passing them this graphics 2D, and then we're going to tell them to draw themselves. So every object that we make is going to have this kind of method. You don't have to call it draw, you can call it something else if you want, but the draw method is going to have all the instructions that this object needs to draw itself. So tell me in either chat, what are the instructions that this object needs to draw itself? What does it need? So this draws the object to the panel. What are the instructions that we need? There's going to be several, right? We got to draw the snakes. We got to draw the snake's outline, fill in the snake's body, draw the eyeball's outline, and make sure everything is in the correct color. So how do we do that? It's a lot of work. A lot of work indeed. Well, let's start with setting the color to, let's go with the base color of the snake. Alright, what next? What do I do next? In fact, I'll put in some placeholders here. At some point, we're going to set it to the base color of the snake. At some point, we're going to set it to the eye color of the snake. And at some point, for the outline, we're going to use black. These are in no particular order. And then there's going to be some other commands in there that I'm missing. Oh, which ones are those? What other commands am I missing? What other commands am I going to need? I'm going to need a fill. But which fill? There's a few fills. So there's a fill shape, a fill 3D rect, fill arc, fill oval, fill polygon. Which of the fills am I going to need in order to draw the snake's body? So fill rect is a bit of a trick here, and I did see a few people who came to office hours trying to use fill rect for the homework as well. You can, that's fine, but fill rect creates a new rectangle for you and fills it in basically. But you already have a rectangle. You have snake's body. We call it body. It's a rectangle. Then you can fill any shape in Swing by calling g.fill and then specifying the shape as an argument. So in this case, if I pass body to g.fill, it will fill in the body. And even though the body and the eyeball are different kinds of shapes, the body is a rectangle, the eyeball is an oval, Swing's able to do that. We'll see why in a few weeks, but for now, all you have to know is that fill will fill in any of the basic shapes that come with Swing. So rectangle, ellipse, what have you. You can also fill in polygons and other neat shapes, arcs, all these different cool things. But for now, we're just going to use rectangles and ellipses. We can fill in the body and the eyeball with fill. Likewise, we can draw any shape. Remember, draw draws the outline of the shape. Fill fills it in. Draw draws the outline. The same way, we can pass the shape in as an argument and use g.draw, again with the shape as an argument to draw the outline of any shape. So this is actually the correct order, I think, that everything goes in. We draw the body first in the base color, then we switch to the eye color and draw the eyeball, and then we switch to black and draw the outlines for everything. I believe this is accurate. And so without further ado, let us bring our snake to life. Let's go back to the panel and create a new SNCC. So SNCC equals new SNCC, and we're going to place him at 50/50. We're going to give him a length of 100 and a height of, let's say, 20. So he's a relatively fat snake as far as snakes go. Now, how do I draw this SNCC to the screen? So I've created him at the top here in the panel. Now, how do I draw him on the screen? How do I draw the SNCC to the screen? Where in panel do I put the code to draw the SNCC? How does it happen? It's going to be in paint component. You got that right. So what's it look like? What line do I put in paint component to draw SNCC to the screen? SNCC.draw is correct, but draw takes a graphics 2D as an argument. So we're almost there. It still needs an argument. Luckily, Eclipse is here to help. We need to pass the pen to SNCC's draw method. Remember, you can't draw anything unless you are holding the pen. So you must pass the pen to SNCC in order for its draw method to succeed. That's why the draw method takes that graphics 2D as an argument. It's so the panel can pass it along to the SNCC, and then the SNCC can draw itself. If you don't have the pen, you can't draw anything. So we have to give it that G, that graphics 2D that we have as an argument. So if we run this, we're going to see a beautiful SNCC right there with its lovely shiny green eyeball. I don't know if you can see the eyeball. It's quite small. So let's go and try to make it bigger maybe. Let's do a 300 by 60 snake. That should give it a nice big eyeball. Ooh, this time we got a purple eyeball. Lovely. Ooh. Let's make another snake. We'll call this guy the green snake. The green snake will be even larger. He will be 400 by 80. Well, let's keep him 400 by 60, and we're going to make him green using our other constructor that also takes a color. And I will place him in a different location. Let's place him at, let's say, 50, but 200, so further down somewhere on the screen. So let's run this, and now, where's my green snake? What a ripoff! Why isn't my green snake anywhere? I made it. I want to see a green snake, and I want to see it now. Where is it? Why isn't it appearing on the screen? What did I forget to do in order to get my green snake to show up? That's right, I forgot to actually draw him in paint component. Nothing gets drawn until it gets drawn, right? So there's no magic to it. It has to get drawn in paint component to appear. There's green snake. There he is. Green snake, you old champion. Alright, now let's say that I want the snake's eye to change color, but only when you click it. So anytime you click a snake in the eyeball, I want it to change color. So let's look at how I might pull that off. And this is something that you'll probably have to do for your homework as well. So both ellipse and rectangle and all the other primitive shapes have a contains method, just like the one that we wrote in the previous homework. So I'm going to write a contains method for snake. Public boolean contains. Okay, so I've written a contains method for my snake here. And if I want to check if you've clicked inside of the eyeball, I'm going to take the point that you've clicked as an argument. Remember to import Java's point and not the one from your previous homework when it gives you an option. So import the java.awt point, not the one from your own assignment. I shouldn't have had you name it point, so that's my bad there. And if the eyeball contains that point, so remember eyeball has a contains method just like we wrote on the homework. So if the eyeball contains that point, then we're going to return true, and otherwise we're going to return false. Okay, so really I should probably call this something like eyeball contains. Let's say returns true if this next eyeball contains the given point. It's true if this next eyeball contains the given point. And if you click inside of that point, I'm going to recolor the eyeball. Someone asked why your Eclipse is running the wrong main method. So make sure, remember that you have to have the driver open, because that's the one where the actual main is. If you've got the panel open, there's no main method in the panel. So if you wanted to run a new program, you're going to make sure you have the right driver open. And since we named them all drivers, sometimes you will just have the one from a previous example open accidentally. That's the most common mistake, probably. Let's regenerate the snake's eyeball color. One way to force it to run the one you want is right-click on the package you want to run and go to Run As Java application there. That will make sure that you're running the one that you want for sure. So right-click on the package you want to run the driver from, go to Run As Java application. If that doesn't appear, like if you don't see Java application, then you don't have a main method that Eclipse can see inside of that class anywhere. Or if that doesn't work, then you don't have a main method Eclipse can see. Public void change eye color, or I guess we can say randomize eye color. Go with that. And do we have to write anything here? Randomly generate new eye color for this snake. Do I have to write anything for this method? Let's think about that. Do I have to write anything here? I won't take a poll because we're short on time, but the answer is no. I can just copy it. I've already done that. So don't rewrite things that you've already done. And more to that point, once you have a method for something, anytime that code appears, use it. So go back, now that you've decided to add a method for this, and replace all the times when you randomized the eye color before with a call to this method. It's much easier to read randomize eye color than it is to read that big old line, so now you know what the constructors are doing in a much more succinct way. Alright, so I've got my randomize eye color method, I've got my eyeball contains. Let's put it all together in the display. When you click, I'm going to change this to E because I don't really like the name arg0. When you click, I want to see if the SNCC eyeball contains your click point, e.getPoint. Then we're going to call SNCC's randomize color method. That's one way to do this. The other way to do this would have been, rather than returning true here, we could have just run the eyeballs contain, or the randomize eye color straight from our eyeballs contains. That's the other way to do it. Up to you how you want to do it. I prefer it this way. Both ways I think will keep you under the line limit for the homework. And I want to do this for the green guy as well, so I'm going to do this for the green guy too. I'll leave it to you to figure out how to do it for an array of objects. Okay, and I'm going to run this, and we're going to see that as I click the eyeball, nothing happens, and that's very disappointing to me. But here's a hint. If I resize the screen, it does change color. So what did I forget to do? The classic mistake. I forgot to repaint. That's right. So if you don't repaint, nothing happens. So now you can click on these eyeballs and get a beautiful strobe. Small epilepsy warning here. Click that eyeball, you get a strobe too. Anywhere else, nothing happens. Alright, I'll upload this example to Canvas. That should be everything you need for the homework this time around, which I've extended to Tuesday. I'll see you guys on Thursday for the exam. You'll have the full time starting from 2 o'clock to do the exam. Again, you're going to be writing code, so make sure your Eclipse is all set for that. And that's it. See you then. If you have any questions about the exam or you want to see me, I'll be very available for the next couple days, but then not so much beyond that. So if you have any questions, reach out to me today, tomorrow. I won't have quite as much time on Thursday. Okay, see you Thursday.